it up on here so I can make sure. Hopefully we've got Jack and or possibly Noah with us today. We'll see once it loads. Here we are. Yep, there's Jack. Excellent. Good morning, Jack. Or good afternoon, I suppose, or evening, or whatever time it is there for you. All right, well, so let's get to it. So what we wanted to talk about today was the last time we talked about branching, and we had both an example of a conditional and an unconditional branch just to set up basically a simple for loop. Um, but what I wanted to talk about or start talking about was branching that involves linking. So um, the uh, what happens with linking is that the program counter, we need to store the value of the program counter so that we know where to go back to um, in a after we finished a subroutine. Okay, and um, in the example that we had last time, we didn't have to uh, store the um, that value because the let's see how to put this. The subroutine we wrote was really simple, and so it wasn't really a big deal. Okay, but the where that stuff got stored um, onto the stack, we didn't put anything else onto the stack, and so we could just kind of assume that things would be there where they were. But that's not necessarily going to be the case for all subroutines, and in particular. Um, what can happen is that if a subroutine is really complicated, it may itself be using the stack and it may itself be changing all of the values of the registers. Okay, so when you pass to a subroutine, you can't necessarily assume that registers are going to get preserved. Some will, some won't, but we'll talk about that in more detail. So, probably the best example of a function where we have to do branching with linking is with some of the C standard functions that do things like printing to the console, reading from the console, etc. Okay, so let's just write actually a really simple function here in C. So I need to, let's see, make sure I remember this. Um, so we need to include um, let me make sure I've got the syntax right on that because I don't ever use C. So basically, all that does is I always forget if it's include or import. Yeah, yeah, okay, but no space. Okay, that's what I thought it was. So basically, we just need to include in C, right? We need to load in the library for standard input output, which is why it's called stdio. Okay, and then I'm going to make a simple function that's going to do absolutely nothing, except it's going to print that. Okay, so let's save this as, say, we'll call it branch.c, and then let's compile it, run it, and see what happens. Okay, so just slide over here. We need to go to the projects directory, and I called this branch and link, and so we need to do okay. and all it does is it prints hello world to the console. Um, I could have put a carriage return at the end of it that basically would have been like the equivalent to pressing enter, so that it doesn't so that the next console line would be the line below it rather than that same spot. But for now, who cares? Um, but why don't we look at what the and no, Jack, the space doesn't matter here. So, um, but why don't we look at what would happen if we assemble this, right? So if we run that, okay, to generate the assembly version of it, let's see what we get. Okay, so if we go over here, okay, and um, let's just remind ourselves, why did I call this branch.s and not branch.asm?
Because machine made it.
Yeah, because the machine made this assembly, not me. Okay, so I'm going to use ASM for any assembly that I make, and .s for any assembly that the machine makes, and that way I won't screw up which is which. Okay, that's just the the convention. Okay, so let's just kind of look at what we've got here, right? So, all right, there's a bunch of stuff in the headers, right? And in particular, we've got this chunk of stuff here, namely that we have a string called hello world. Okay, that makes sense. And then let's kind of look at what's going on in the main function. Um, the this LFB0 thing, right? That stuff is stuff that the compiler is putting in, right? It wouldn't be there in handwritten assembly. Um, okay, it's doing some stuff with the offset. It's this line right here, okay, is something that is important to use um, basically at the beginning of programs because uh, you need to basically, so what are x29 and x30? Those are the stack pointer and the frame pointer. Now, the frame pointer we'll talk about more later. The stack pointer is basically just where is the top, or really the bottom, I guess, of the stack. Okay, and we're just going to store that information, um, or sorry, the value of those registers onto the stack. Um, and the way the stack works, and again, we'll talk about this more as we go on. The stack grows downward. So if uh, so if there's a memory address, okay, let's say that's memory address 100, say, and you put something onto the stack, then the stack pointer you subtract from, so that the stack is now so you want to think of it as it sort of starts at 100, memory address 100, and then grows downwards, going backwards in memory to memory address whatever. Okay, and so the stack pointer is going to basically tell you where is the um, well, it's either the top of the stack or the bottom of the stack, depending on your point of view, right? It's the bottom in the sense that it's pointing to uh, that it's going to be a lower memory address than the stuff above it. Or you could just kind of think of everything as being upside down. And what is a stack? Would you guys like in data structures? What was a stack? Yeah, it's just like literally it's as if you've got a stack of papers, right? And you can take something off of the top of the stack, or you can put something onto the top of the stack. Um, or and when you do that, right, your stack pointer is going to tell you what memory address is where the top of the stack is. Okay. Now on ARM and Linux, the stack, hi Evan, the stack grows downwards. So it grows from a higher memory address down to a lower memory address. Okay. And so do you want to think of the stack pointer or the stack is like, well, this is hard to say. Words are difficult without coffee. Which direction do you want to think of it? Do you want to think of the top of the stack as being really the bottom of the stack in terms of the lower memory address, or what? Okay. Um, so anyway, so what we're doing there with this store pair is storing those two things to the stack and then also expanding the stack by an extra 16 bytes. Okay. And this is why it's a minus there, because since the stack grows downwards, the stack pointer, when we expand, goes to a lower memory address. And so we need to subtract 16 from it, not add 16. Okay, does that make sense? Um, yeah, okay. And that's only because the stack grows from higher memory into lower memory addresses. Okay, now, what else is going on here? Well, we've got something going on here with um, x0, okay? But then it's printing here, or sorry, to branch to the printf function, we need to do branching and linking, okay? And the reason is that the printf function is really complicated, and it's going to be doing who knows what under the hood to make it. Sorry, sorry, Jack. You had to listen to me sneeze. Okay. Um, oh, yay! We got our first spammer on Twitch here. All right, let's see if I can ban him. The spammer is SN Max and then a bunch of digits who says, want to become famous? Buy followers, primes and views on bigfollows.com. Okay, so, yeah. Account created September 8th, 2020. Uh-huh. Yep. All right, so that would be, we are going to report this person for spam. And I think this is a bot account. And um, I'm going to block them. Okay, congratulations, my first bot. Okay, all right. Anyway, so the printf function is going to under the hood going to be doing whatever it's going to be doing, and so we don't necessarily know um, what what it's going to be doing. It probably is itself going to use the stack. It's going to be using registers of all varieties, and uh, yeah, okay. So in this case, what needs to get passed to the function printf for it to do its thing? Well, what are we printing? We're printing a string, okay? And so in this case, there's only one piece of information that really needs to get passed to printf, and that's the location of the string in memory, okay? Now, how does it know when it's gotten to the end of the string? There's a null terminator at the end of the string, okay? So if it knows, hey, I'm printing a string, and this is the memory address it's going to start in, I'm just going to start dumping ASCII to the console, okay? And I'm going to stop whenever I hit the null terminator that's at the end of the string, okay? So hello world as a string, how is that stored in memory? Yeah, it'd be an ASCII, okay? So there'd be a byte for each of the characters there, and that includes the space. Okay, that has its own character code in ASCII. Okay, so we'd have 5 characters for hello, a space is 6, 5 more for world, that's 11. The exclamation point would be 12, and then the null terminator would take a 13th that doesn't look like it's there, okay? The null terminator is just a byte that has all zeros in it, okay? So that would be 13 bytes, okay? And the printf function is just going to start reading 1 byte at a time and printing out the appropriate letter to the console. And then when it hits the null terminator, it knows it's finished, and then it's done, and we return back to the to our program. Okay, so what has to get specified to printf basically is the memory address of that where that string starts. Okay, which is what all these two things here are doing. Although when we handwrite this, this will be a little bit easier to deal with. And then let's see. Yeah, so this won't look quite as complicated when we handwrite this stuff. But then after we return from printf, we basically are going to see how to put this. Undo what we did, and then that's sort of the end of it. Okay. Okay. So this is, like I said, I mean, this is one downside to looking at machine assembled code is that it doesn't look very user friendly. Okay. So what we need to do to sort of hand assemble this is let's just start basically a new file that would do something like this. Okay. Um, but would but we're going to write it by hand. Okay. All right. And so to do that, let me actually I'm going to also open just for my own reference the where did I put it? My my chocolate example. This is just for my own reference. Um, okay, so um, right, okay. So where is there it is, okay. So let's go back to here, okay. Let me make a new file and I'll call this one branch dot, well, let me just do branch 2, just so that we don't mix up which one we're talking about when we compile it, okay. Um, all right, so I'm going to have um, a string, okay, and then uh, this is one way to do it. Okay, so this is in the data section, right? So we'll have data, okay, and then I'm going to have text and global main. We'll have our main routine, which will finish at wherever. And then down at the bottom, although I don't have to put this at the bottom, I'm going to um, um, okay, so I need to put, that's right, I need to name this. Okay, and then down at the bottom, sorry, so we get the, I'll do that. And then down at the bottom, I'm going to put, what was it? The address of the print format. And D word, okay, string name. Okay, So what's going to happen here is, what is it that I need to pass to printf for it to do its thing? Well, I need to pass to it the address of the string that I wish for it to print. Okay. Now, as we'll see in a minute, there are other things that I could pass to it besides just an address. Okay. Um, so I've got a string, and I just called it string name, whatever. And then I also have down there at the bottom the address. I've called another thing address of that string. Okay. And it's a D word because, um, well, what what kind of things are going to be storing memory locations here? Okay, how big are memory addresses on this machine? What kind of architecture are we dealing with? Well, it's a 64-bit machine, right? Right. So the registers are all 64 bits wide, and the address space is 64 bits. Okay, so I need to, if I want to have a memory address location, that's going to be a 64-bit object. Okay, um, wherever it is. Okay, and then what else do we need to do? Well, let's see. Um, I need to load x0 with that address. Okay, so this would be load x0 with the address. Oops. Oops, it would help if I could type today. With the address of the string. Okay, and then I need to branch to it. Okay, and okay, and that'll do that. And then let's see, the last stuff I need to do is I need to make sure that I do my stack pointer business. So that would be, I'm just going to copy, and that should actually be x29 there, not x19, but that's okay. Oops. Okay, so x29, and then down here at the bottom, I need to load the pair x29, x30, stack pointer 16. And make sure I got the format right. Yeah, okay. All right, so store that, load the address. Okay, so we should be good. Let me actually just move this down. I don't think it's actually going to matter, but I'll just move it there for cleanliness. Okay, so let's assemble this and make sure that I didn't screw anything up. All right, so let's see. We need to assemble. I called this one branch2.asm. I'm outputting to branch2.o. All right, so what did I screw up here? Unknown mnemonic, string name. All right, so now for the fun debugging. Oh, I forgot a colon, that's why. Yep, and I need a colon right here. Okay. Oh, did I save it? Oops. Okay. All right, what am I missing here? I put colons. Oops. All right. this is interesting. Maybe it doesn't like the dash. Huh, okay, it just didn't like the dash for some stupid reason. All right, whatever. So then let's take branch 2.0, and then we're going to output to branch 2, and then if we run it, right, there we go. Okay, so it did the exact same thing that the other program did, although this is a little cleaner looking, hopefully. Okay, so what did we have to pass to the string? I mean, to the printf function. What information did it need to do its job? Yeah, it needed a string. Okay, well, you can't just pass it a string. Okay, because a string doesn't fit into a register. Okay, but what does fit into a register? The memory location of it does. Okay, so when what this basically what we're getting into is how do you really pass parameters to and from functions, right? So in Java or C or Python or whatever language, right? You guys all did Java, right? At some point, um, you wrote functions where, like, you might pass it 16 different things. You might pass it a string and a bunch of numbers and some booleans just for good, right? Whatever, right? So you passed all of these pieces of data to a function that you were writing. The function did whatever it wanted, whatever you wanted it to, and then it possibly returned some other values back to your whatever routine called it. Okay. So when you did that, how were those parameters actually getting passed to the functions? Like, so when you wrote this in C, right? So if I did like in or Java, right? I'm going to write a function that say int func of a pair of ints, and then you pass it two integers and it spits something back, right? What did you do? You specified, okay, I'm going to give it two integers, and they're going to be called this, and then I'm going to spit back an integer and it'll be called that, right? Okay, and then you compiled it and just magically stuff happened. Yes? So what's really happening? If you want to pass a function two integers, where are those integers going to be? Well, where do you think they're going to be? There's only two answers to this, possible answers to this question. They're either going to be in registers or on the stack someplace. Okay. The convention with ARM64, partly also with Linux, is that the memory address, or sorry, not the memory addresses, the registers 0 through 7 are there for you to use for parameter passing. Okay. So that gives you the ability to pass up to 8 parameters at a time to and fro. Okay. Um, and which one should you use first? So, like, let's say you want to pass 3 parameters. Which registers should you use for that? Yeah, 0 through 2. Okay, so the convention is you start with 0 and then you use however many you need to. Okay. Um, if you need to use more than 8, then you have to start using the stack, and that's something we'll look at, like I said, a little bit later. Okay. Um, and then when you're receiving values back, you should obey sort of the same convention. Okay, that 0 through 7 are in order going to be whatever your outputs are. Okay, so for example, let's go back to the C program. Um, let's take this guy here. So I didn't actually put this in here, but I could have. Right, if I return 0, that's going to return 0 to the process that called this program. Okay, in this case, that'd be the operating system. Yes. Well, where is the compiler going to put the return 0 command? Or, sorry, how is it going to do that? Right, so what does return 0 from C turn into in the assembly? It's going to load X0 with, or W0, either one, with the number 0, and then it'll be a ret, okay, which will go back to the calling program. Okay, so Linux is assuming that the exit status is going to be whatever's in register 0. And so it, you remember when we were running the GNU debugger last time and it said exit status, blah, blah, blah? Well, all it's doing is saying what was in register 0 right when that program terminated. Okay, and then it's calling that the exit status, and that's sort of the convention. Okay, okay. So for things like numbers, we can put them in registers to pass them to and fro because they fit into registers. But there might be other things like arrays or strings or compound objects that you make, like you know, stuff that has multiple pieces of data within it. You know, a struct, or what is it called in Java when you do this? When you, like, let's say that you make like an object that has like object customer, and then it would have a subfield for like customer name, customer phone number, and what, yeah, okay. So I think it's called a struct in C, but okay. But point being, if you make some sort of complex data object that has a bunch of stuff in it, none of that stuff is going to fit individually, or the whole object won't fit into a register. Okay, so when you're trying to pass that to a function, what are you actually going to pass instead? The memory address of it. Okay, because if you can't fit the data into a register, you can't pass it that way. Okay, so in this case, let's go back to the branch 2.asm. What I'm doing, let's see which keyboard. Here we go. This one, right? Is I'm loading X0 with the address of the string. Okay, so the string is going to be in memory someplace, and its starting memory address is whatever. That's the thing I'm going to put into X0. Okay, then I branch to printf, and what printf is going to do is it's going to look at what is in X0. Oh, it's a memory address. Okay, oh, there's a string there. Okay, I'm supposed to print things because that's the purpose of the printf function. So it's going to start reading through it and saying, oh, okay, this is a string, great. And there's a null terminator at the end, so I'll just print until I hit the null terminator, and then good, I'm done. Okay, back to the function. Okay, okay, so that's all well and good, but do we just use printf for printing strings? No. What else do you use printf for? Um, well, okay, you know what? Let me do it this way. Let me go back over here. Okay, so this chocolate program that I made, let me just switch directories to that for a second. Okay, what does it do? It does some arithmetic. Okay, who cares? How? But then what is it going to do? It's going to output a string and a number. Okay, so let's look at the code and see how I made that work. So if I go here, right? Let's look at the string that I defined. Okay, so what do we see inside that string? And I don't remember exactly how you had to deal with this in Java. Um, yeah, what's that percent %LLI \n business going on? Huh? Yeah, the \n is just the carriage return that hits enter at the end. Okay, so that part's easy. But what's this percent %LLI thing mean? Yeah, it's the percent. So that part of it is what's called a formatting string. Okay, so if I want to print a string but also have it replace um, uh, so like in this program, what did I want it to do? I wanted it to say the answer is, or output is, sorry, and then it sticks a number there. And the number that it sticks there was the result of it doing some sort of arithmetic. Okay, so um, so let me back up just 1 second. Did you guys all see I posted a new assignment on Canvas? Okay, what's the assignment? Yeah, to redo the triangular number thing, but this time with ARM assembly. Okay, there will be a subsequent version of this assignment, which is to also include console input and output. Okay, the first version of it, there is no console input and output, so just hard code everything and look at it in the GNU debugger to see that it's working. Okay, um, then we'll layer on the console input output to it. Okay, so in this particular program, right, I could have console input to say, for example, what number do you want me to use? And say the user types in 5, and the program does some stuff and then spits out whatever the result of that computation is. Okay, then if I want to display that information to the console, then I need to tell printf what kind of data to expect. Okay, and the way that I do that is with putting things like this percent %LLI into the string that I wanted to print. Okay, so what is percent? The percent tells you that it's that what comes next is going to be a format thing. Okay, and then what about the LLI? What do you guys think that stands for? I is input, or what else could I stand for? Integer. Okay. What kind of integer? Well, it's a long. It's a 64-bit thing. Okay. Right. Um, or actually, this probably would be uh, li would be sufficient here because, right, what is an int in the 64-bit OS? It's a 32-bit thing, and therefore a long int. When I wrote this code, um, I was writing it on a different version of the operating system, and in that version, you had to say long int, not just long int. Okay, but what printf is going to do is it's going to get this string and it's going to see the percent %LLI bit in there, and it's going to say, ah, that's where I'm supposed to replace with a number. Okay, where is that number going to be located for it? Well, if I passed the string's memory address in x0, where would the next thing need to be? x1. And if I wanted to print two numbers, where would the number after that be? x2 or w2, depending on the size of it, right? Okay, and so on. And if I want to print more than that, so more than, well, 7 things, then I'm going to have to start using the stack. And like I said, we'll talk about that more later. Okay, so does that kind of make sense? We need to give printf a string that may or may not include formatting information. okay, to tell it what kind of data to be expecting and then replacing with. And then secondly, we need to specify the memory address of the um, uh, the string itself. Okay, does that make sense? All right, so let's um, let's actually go into our example here, and let's start adding a few things. Okay, so for example, okay, so let's say we did this. Okay, and I don't know how many lotteries only have two numbers, but you guys will. Well, let me just say lucky number. How about that? Okay, if I assemble this right now, what's probably going to happen? Oops. Okay, probably because what is printf going to be expecting? Two 64-bit integers. Have I put anything into x1 or x2? No. Okay. So let's run or assemble and run this and see what happens. What did I call this? Branch link, and then I need to do, let's see, AS. Okay, so what did we get? Exactly, whatever was already in registers 1 and 2, which is, from our standpoint, might as well just be garbage, right? We didn't stick numbers in there. Those things were whatever happened to be in those registers before our program started. They are, okay. Well, no, they're not lotto numbers, they're lucky numbers. Okay, yes. Ah, good point. Yes. Evan's question was, that's an actual number, it's not in hex. And yes, that is a base 10 number. Okay. And the reason that I know it's in base 10 is actually, let's go back to the format string. This actually tells printf to print it as a base 10 integer. Okay. Um, Now, how else could I ask it to print things? Maybe I do want to see it in hexadecimal or binary. Okay. Um, and actually, to do it in hex, all you have to do is just change the I to an X. Okay, so if I do this, LLX instead of LLI, it's going to display that data as a hexadecimal is how it'll print it. Okay, so let's reassemble and rerun it. And we see the exact same, well, um, it's those values are again whatever happened to be in those two registers when I ran the program, but now I'm outputting them in hexadecimal instead of as a base 10 number. Same data, right? It's still coming from registers 1 and 2. It's just that I've told printf to print it in hex rather than um, in base 10. Okay, is that all right? Okay, and yeah, if you want something to print in binary and stuff, I don't remember if it's LLB. Let's find out. Um, uh, a lot of these I just have to look up because I don't have them all memorized. Nope. Um, yeah, I don't remember what it is. So we'll just look it up. Okay, so where do we find this sort of stuff? So Okay. So just find some reference, right? And, you just look these things up. Okay, so new line, carriage return, horizontal tab, right? So you can do stuff like that. But then what are the other formatting screen? Okay, string, digit, floating point, a number in octal, which octal is kind of, I don't know of anybody that actually uses it anymore, but some older machines did. Do you guys know what octal is? Yeah, it's like hexadecimal, but instead of going up to 16, you only go up to 8. So if hexadecimal, each character in hexadecimal was how many bits? Or each hex symbol represented how many bits? 4, right? Okay, because there's 16 different patterns with the four bits. Octal, you take them not 4 at a time, but 3 at a time. And so the digits in octal are only 0 up through 7. That's it. Okay. Now, I mean, that's a perfectly good system. Why do you think it fell out of fashion? Well, we did, but also 3 is an annoying number, and it's not a power of 2. Okay. Um, so, yeah. So that's all that octal is. It's just it's like hex, but only 0 through 7 instead. Okay, whatever. Floating point, obviously, we'll talk about later. Because that will become important. You can put commas in. You can add leading zeros. This is not what I wanted, so let's just do printf binary. Uh, no, it was outputting like the file names for JPEGs. So like, let's say you're writing a program that was dumping a bunch of images to a directory, then you could use that to name them. Yeah. Okay. So oh, of course. Guess what? It's not built in. Yay, that means you guys get to write it. Yeah, okay, excellent. Okay, so, all right, fair question, but I could have sworn there was something built in to do that, but I guess not. Um, okay, but anyway, so the format parts here, right? Each time printf sees one of these objects, LLX, LLI, whatever, right? F for floats. Um, it's going to replace that with a number, okay? And it's going to replace them in a particular order, right? So in this case, I have two 64-bit things is what it's expecting. Where is it going to look to find those things? In registers 1 and 2, okay? What about if I asked it to print a 32-bit number? Where would it expect to find that? Okay, still 1 and 2, but W1 and 2, not X1 and 2, okay? And if I asked it to print a floating point number, where is it going to expect to find the floating point number? Okay, it's not going to be an X1 because X1 stores integers, not floats. It's going to look in whatever the first floating point register is. Okay, and the floating point registers are called S or D for either single or double precision. Okay, and so it would look in S0 or D0 depending on what kind of float we were passing for it. But it's always going to go in order from 0 or 1 on. Okay, If you want to print, like, let's say I wanted to print out 10 different numbers all at once. That's not going to work, is it? Okay, what's the problem with trying to print 10 different numbers? How many things do I need to pass to printf to print 10 numbers? Well, actually 11, right? Why is it 11? I need a string, a formatting string, okay? And then the 10 things that I wish it to print. But if I can only pass stuff using registers 0 through 7, 10 is bigger than 8, last time I checked, and so we have a problem. Then we have to use the stack. Okay, we'll talk about that more later. Okay, now you see the string that I have here, how it has actual text in it in addition to the format things, right? You don't have to give, like, the fact that I've put hello world and lucky numbers or whatever doesn't have to be there. All printf is expecting to see is a formatting string, okay, that has the things that the kind of data it's going to be expecting. Now, when I originally typed this and I had that, okay, before I put in the formatting string stuff, it's going to look at that and it's going to say, oh, are there any format codes in there for me to read? Nope. So I'm just going to print out the string as is, and there's nothing for me to replace with, so I'll just dump stuff to the console. Okay, so what about if I had something like, oops, like this? Okay, what's going to get printed? Well, what do you think? Just a single number, okay, in hex, whatever happens to be in register X1, okay? So the string can be at bare minimum that, right? So there don't have to be words in there. If you're printing things for the sake of the user, then that's probably a good thing to have words in there to tell them what you're giving them. Okay, so the string can have no text, like it is here, where it would just be you're replacing with a number, or it can be only text. So, for example, that would be like when we had this. Okay, there, is printf going to replace anything with something that's sitting in register 1 or 2 or whatever? No, it doesn't care because I didn't tell it to. Okay, so your prints can be as simple or complex as you want them to be, and in particular, actually, this is kind of cool. Let's go back here to this thing here, right? So what did this person say to do? He said basically to write a program that uses printf and prints either ones or zeros. Okay, could we write such a function in assembly to do this? Okay, how would it work? Well, it would need to take a number, okay? It would need to look at whichever bit we're interested in at that moment, and then it's going to print either a 1 or a 0. So you notice how that printf command there doesn't have any formatting string. It's just literally printing the digit 1 or 0, and that's it. Okay. Yeah, man, I'm just going to come up with all kinds of great exercises for you guys. Yeah, yeah. But you guys are learning so much. Yeah. Okay. Anyway, um, so the if I had, for example, um, um, let's say I did um, well, okay, yeah. Um, the sorry, what was I going to say? I of course could use multiple strings, multiple formatting strings. I can call printf however many times I need to, right, and so on. Okay. All right, so let's pause. Questions, preguntas, fragens. Mhm. I know it's 9 in the morning. You guys are tired. I'm tired. We're all tired. Um, oh, the backslash in? Well, it's start a new line. Yeah. Should be, yeah. So let's assemble it in. Yep. Okay, but notice that the second line doesn't terminate because how would I terminate that? I'd have to put another backslash in. And then while we're at it, let's do that. Okay. Right. So you can kind of form sort of a compound object here. Um, so there I used printf. Notice that that was only one function call to printf, but it did three different lines. I could have also used printf for each individual line. Okay, that would have also worked, right? Yeah. Huh? Oh, sure. All right. So the listing file. We need to do. Oh, Nano and then the file name. So all Nano is a console text editor, right? I mean, I could have opened this up with Genie too, but I like looking at the red. So yeah, okay. So this is actually kind of cool, right? So what's going on up here? Okay, what's all that stuff? Well, how does the string get encoded? Yeah, all right. So if we want to know what the string is going to look like, we have to look up what each letter is on the ASCII table. And of course, this is in hex. So, um, all right. So we'll have our string is encoded in hex, in ASCII hex, okay, up there. And then if we look down at our code part, what all do we have? Well, we've got, um, okay, so some of these things are the usual suspects, right? Um, so the um, like our there we're loading x0 with the address of something, okay? And then so what particular part of the listing file were you interested in seeing? What it looks like? Okay. Well, I mean, it looks similar to what we've seen before, right? In the sense that each each line of assembly is some sort of operation, okay? Now, the branch and link operation, okay, this is kind of the funny part, right? Is that, and this is where GCC comes back in, right? Because what do you think branch and link needs to be specified? Okay, to branch and link, what do you need? Well, to branch at all, what do you need to do? You need to branch to a memory address. Okay, what does it look like the memory address that we're branching to is right now? Okay, if 49 or sorry 94 is probably the opcode here. What's the rest of that command? Yeah, now I'm certainly not branching to memory address 0 to do something, okay? But this is what GCC does, is it's going to link things, and um, printf or whatever is going to be located in some sort of memory address, that particular piece of code. Now, do I know where that is right now? No, but the operating system does, okay? And so what it's going to do is it will replace that part to make sure it points to the correct thing, um, which that part's kind of magic, frankly. Um, whereas if we look at, let me actually do this. Okay, this is the entire actual program. Okay, the executable. Which doesn't that look way longer than what we've got with our listing file? Yeah, and that's because we've linked in stuff. Okay, and how that exactly works, honestly, I don't know. It might as well be magic, huh?
The executable file.
Yep, that's the actual. What I did there was I did a hex dump, which just takes whatever's in that executable file or any other file for that matter, and dumps it in hex, right? Hmm? Well, nah, maybe it's not. It might as well be magic. It's that um, this is the kind of thing that I think you would study if you took an operating systems course, okay, or a compiler's course. Something a bit more advanced than this with that Dr. ML would probably teach. Well, not for this class, okay. Um, it's going to get linked in to the executable, and how exactly that works, like I don't know. Now, the uh, on ancient machines, like, if we went back to sort of the 1980s, right, where there is no operating system, then that's probably a little easier to understand what's going on. But of course, the whole benefit of dynamic linking and stuff is that your executables don't have to have everything in them. They can refer to other things that are already part of an operating system or library or whatever, and you just have to point them to the right place. Now, how exactly you point them there, that's the part I don't know. Okay, but you do. Okay, is that all right? Sure. Yeah, I don't know why it formats it the way it does, um, but notice that it's going up by. Um, yeah, so the thing on the left is basically address, and then you've got the data. I mean, but I can hex dump anything, right? So I could hex dump um, the listing file, right? Now that doesn't look particularly enlightening, does it? But all it's done is it's taken that file and shown me literally as all of its hexadecimal. Um, yeah, so hex dumping is perhaps not particularly useful. Um, but although actually no, we did. I think last time didn't we use a hex dump and we were like, okay, where actually is the load register in this thing? And I used grep to find it. Um, yeah. Okay, so grep basically searches output from something else and finds whatever your matches a pattern. So it's kind of like a find function, but in a console. Um, yeah. Okay. Anyway, um, all right. So what's sort of next here um, that we need to talk about? We need to talk about, well, what happens if you want to print more than 7 things? Okay, because of course the 8th thing you've got to use for your formatting string. What happens if you want to do that? What happens if you want to accept input from the console? Okay, so that would be using the function called scanf as opposed to printf. Okay, and that will get us into knee deep into the discussion of the stack. Okay, which I think would probably be a good place to start Tuesday, as we'll really start about talking about the stack and how that looks and operates and whatnot, and then we'll layer the branch and print, or sorry, the printf and scanf stuff. Okay, now the other thing that we'll have to do here is, so you guys in 111 probably did some sort of exercise along these lines where the user would type a string and you'd have to convert that to a number, or vice versa. Okay, does that sound familiar? Or you take a number and you output it as a string in ASCII. Okay, so you have to do basic data processing to kind of accept and format input and output. Well, we'll have to worry about a lot of those things, right? Because if I am asking the user to type a number in a console, what is it going to be returned to me as? Probably as a string. And then I need to do input validation to make sure that it's correctly formatted and then convert it to a number. And in Java or C, you have those built-in functions that like take a string and return the equivalent number, or vice versa. Well, guess what? We don't have. Right, that. You have to write those manually, right? Yeah. So anyway, all right. We'll quit here today. Have a good rest of your day. Um, and thanks for coming. And looks like, do we still have Jack? No, well, man, we got all kinds of weird random people on here. So, um, yeah.